Okay, so let's consider this limit here. Limit as n goes to infinity of 1 plus 1 over n raised to the n. So if we tried to let n go to infinity, the inside would transform into 1 plus 0, which is 1. And so we're actually dealing with a limit involving 1 to the infinity this time. 1 to the infinity. So again, the process is to apply a log. And let's do the limit with the logarithm in it. Limit as n goes to infinity of the ln of this stuff. By using the logarithm, we're able to bring the exponent out front. And now we've transformed our limit from an exponential one to one involving multiplication. Because as n goes to infinity, this is going to be infinity. As n goes to infinity, the stuff inside there goes to 1 plus 0, which is 1. ln of 1 is 0. So we've transformed this again into an infinity times 0 limit. So we rewrite it as one of those things over the reciprocal of the other. And it doesn't, you can do it either way, but darn it, let's make life easy. And let's put the ln function up on top. ln of 1 plus 1 over n divided by the reciprocal of the other. Okay. And now we have transformed this into a 0 over 0 limit, which allows us to finally apply L'Hopital's rule. So it would be the derivative of the top. So limit as n goes to infinity of 1 over the stuff on top times the derivative of the stuff on the inside. That would be the derivative of 1 over n, or n to the minus 1, which would just be minus n to the minus second. And that's all over derivative of 1 over n, which is also just minus n to the minus second. And so we're able to make those minus n terms go away. And now we can just let n become infinity, because this is just going to be a limit of 1 over 1 plus 0, which would be just 1 all over 1. So the whole thing just approaches 1. And so therefore, the original limit as n goes to infinity of 1 plus 1 over n to the n is equal to e to the first power, or in other words, e. We have this limit that will actually approach e as n goes to infinity. This limit actually approaches e as n goes to infinity.